When you think of Saturn, what comes to mind? Beautiful rings, a peaceful gas giant floating serenely in space. The jewel of our solar system, right? Wrong. Completely wrong. What I'm about to tell you will shatter that peaceful image forever, because Saturn isn't peaceful. It's a hellscape of cosmic violence, happening on scales we can barely comprehend. Storms larger than Earth, winds reaching 1,100 miles per hour, a hexagonal vortex at its north pole that defies the laws of physics. And here's the disturbing part. Scientists recently discovered something in Saturn's atmosphere that suggests the planet is actually getting more violent. Not less, more. But before we get into that, let me show you exactly what makes Saturn the most terrifying planet in our solar system. So let's start with what everyone thinks they know about Saturn. Saturn is the sixth planet from the Sun. It's a gas giant, the second largest planet in our solar system after Jupiter. It's famous for its spectacular ring system, composed of billions of ice particles ranging from tiny grains to house-sized chunks. When people see pictures of Saturn, they describe it as serene, elegant, beautiful. Space agencies love showing Saturn because it looks impressive, yet somehow peaceful. Those perfectly symmetrical rings, those soft pastel colors in the atmosphere. This image is a lie, or rather, it's a lie of omission. See, those beautiful pictures are usually taken from far away. They show Saturn's exterior, the upper cloud layers we can see from space. They don't show what's happening beneath those clouds. They don't show the violence occurring every single second on this planet. Let me give you some context. Saturn is massive. You could fit 764 Earths inside Saturn's volume. But here's what's wild. Saturn's density is so low that if you could find an ocean big enough, Saturn would float. It's the only planet in our solar system with this property. Why is it so light? Because it's almost entirely hydrogen and helium gas. There's no solid surface. If you tried to land on Saturn, you'd just keep falling through increasingly dense gas until the pressure crushed you into atoms. But we'll get to that horror in a moment. First, let me tell you about Saturn's winds. Imagine the strongest hurricane you've ever heard of. Hurricane Katrina had sustained winds of 175 miles per hour. That's devastating, right? It caused catastrophic damage. Now multiply that by 6. Saturn's equatorial winds reach speeds of 1,100 miles per hour. That's 1,770 kilometers per hour. These winds blow continuously, without stopping, creating jet streams that circle the entire planet. To put this in perspective, the speed of sound in Earth's atmosphere is about 767 miles per hour. Saturn's winds are supersonic. They exceed the speed of sound by a significant margin. What would 1,100 miles per hour's winds do to you? Well, first, you'd be torn apart instantly. Your body cannot withstand forces of that magnitude. You'd be ripped into pieces faster than you could process what was happening. But that's not even the scary part. The scary part is that these winds never stop, ever. On Earth, hurricanes eventually dissipate. They hit land and lose energy. Or atmospheric conditions change and they break apart. Earth's hurricanes last days or weeks at most. Saturn's winds have been blowing at these speeds for millions of years, possibly billions, and they show no signs of slowing down. Why? Because there's no surface to slow them down, no friction, just an endless atmosphere of hydrogen and helium with nothing to disrupt the flow. Energy keeps getting pumped into these winds from Saturn's interior heat. The planet radiates 2.5 times more energy than it receives from the Sun. This internal heat drives convection in the atmosphere, creating these monstrous wind systems. And here's something that will blow your mind. Saturn's atmosphere has distinct bands, similar to Jupiter but more subdued in color. These bands are different wind streams, moving at different speeds. The boundaries between these streams create shear zones where the winds moving at different velocities interact. The turbulence at these shear zones is unimaginable. Imagine two highways of wind moving at 1,000 miles per hour in opposite directions, colliding with each other. The chaos created at these boundaries generates storms, which brings us to Saturn's storms. And trust me, this is where it gets truly terrifying. So let me tell you about an event called the Great White Spot. This will change how you see Saturn forever. Roughly every 30 years, Saturn experiences a massive storm outbreak. These aren't ordinary storms, they're planet-scale catastrophes that dwarf anything we've ever seen on Earth. The most recent Great White Spot erupted in 2010. Amateur astronomers first noticed a bright white spot appearing in Saturn's northern hemisphere. Within weeks, this spot had grown into a storm system larger than Earth. Let me repeat that. Larger than Earth. An entire planet's worth of storm. The storm eventually wrapped around Saturn's entire equator, creating a band of turbulence that circled the planet. The energy released by this single storm was estimated to be equivalent to billions of nuclear bombs. NASA's Cassini spacecraft was orbiting Saturn during the 2010 to 2011 storm. It captured unprecedented data about what was happening, and what it found was shocking. The storm penetrated deep into Saturn's atmosphere, reaching layers over 100 kilometers below the visible cloud tops. Temperature measurements showed the storm was churning up material from these deep layers, material that's normally hidden from view. Lightning detection instruments on Cassini recorded lightning strikes 10,000 times more powerful than anything on Earth. These weren't isolated strikes. The storm was generating lightning continuously, thousands of strikes per hour. The radio emissions from this lightning were so intense that they interfered with Cassini's communication systems. Saturn's storm was literally jamming a spacecraft's electronics from thousands of kilometers away. But here's the question that haunts scientists. What triggers these great white spots? We know they occur roughly every 30 years, corresponding to Saturn's orbital period around the Sunday, but the exact mechanism is still debated. Some researchers think it's related to seasonal changes, as Saturn's axial tilt causes different hemispheres to receive more sunlight. Others propose that energy builds up in Saturn's atmosphere over decades, and when conditions are right, it releases explosively, like a pressure valve opening. What everyone agrees on is this: these storms represent energy releases on scales that we struggle to comprehend. They're natural disasters that would make Earth's worst weather look like a light breeze. And they happen regularly. Every generation of humans, Saturn unleashes this fury. Now, let me tell you about something that shouldn't be possible according to our understanding of physics: Saturn's North Pole hexagon. When Voyager spacecraft flew past Saturn in the 1980s, they discovered something bizarre at the planet's North Pole: a hexagonal cloud pattern, perfectly hexagonal, each side measuring roughly 9,000 miles long. This hexagon has been stable for at least 40 years, probably much longer. It rotates with the planet once every 10 hours and 39 minutes, which is Saturn's rotation period. Here's why this is terrifying. Hexagons don't form naturally in fluid dynamics, not at these scales. You can create hexagonal patterns in laboratory experiments under very specific conditions. But a hexagon the size of 2 Earths, stable for decades in a turbulent atmosphere, that shouldn't exist. Scientists have proposed various explanations. The most accepted theory is that it's a jet stream, a river of wind flowing around Saturn's North Pole. The hexagonal shape emerges from the interaction between winds at different latitudes, traveling at different speeds. Laboratory experiments have successfully recreated hexagonal patterns in rotating fluids, lending credence to this explanation. But here's what keeps researchers up at night. We still don't fully understand why this particular geometry is so stable. Inside the hexagon is a massive hurricane, larger than Earth, spinning at the pole. This hurricane has been observed with a clearly defined eye, similar to Earth's hurricanes but scaled up to planetary dimensions. The wind speeds in this polar vortex exceed 300 miles per hour. The eye alone is 1,250 miles across. For comparison, the eye of a typical Earth hurricane is 20 to 40 miles wide. What makes Saturn's hexagon truly unsettling is its persistence. Weather patterns on Earth change constantly. High-pressure systems, low-pressure systems, they move, evolve, dissipate. Nothing maintains the same shape for decades. Yet, Saturn's hexagon does. It's been photographed countless times by Cassini over 13 years. Always there, always hexagonal, always rotating. Some researchers have noted that the hexagon's appearance changes with seasons. During Saturn's northern winter, it appeared darker. As northern spring arrived and sunlight hit the pole, the hexagon became lighter and more defined. This suggests the hexagon extends deep into Saturn's atmosphere, affected by seasonal energy inputs, but fundamentally stable in its structure. It's like Saturn has carved a permanent geometric scar into its own atmosphere, a reminder that we don't understand this planet as well as we think we do. Let's talk about what happens if you actually try to enter Saturn's atmosphere. This is where the true horror begins. Imagine you're in a spacecraft approaching Saturn. From a distance, it looks beautiful. Those rings, those cloud bands. You decide to descend into the atmosphere. Initially, everything seems fine. You're passing through the upper atmosphere. It's thin, mostly hydrogen. Temperature is cold, around negative 180 degrees Celsius. But your spacecraft has thermal protection. No problem. You keep descending. The atmosphere gets denser. Pressure increases. You're now at the level of those beautiful cloud bands you saw from space. Ammonia ice crystals form the visible clouds. Wind speeds have picked up. Turbulence buffets your spacecraft. Deeper, the atmosphere is now getting thick. Pressure is mounting. You're several hundred kilometers down. The hydrogen around you is becoming denser and denser. Temperature is rising due to compression. Keep going. Pressure is now 10 times Earth's atmospheric pressure, then 100 times. The hydrogen is so compressed, it's behaving strangely. Your spacecraft's hull is groaning under the stress. 1,000 times Earth's pressure. The temperature is now several hundred degrees Celsius. The hydrogen is transitioning from gas to liquid, not through cooling, but through pure pressure. You're swimming through liquid hydrogen. Deeper still, 10,000 times Earth's pressure. The temperature exceeds 2,000 degrees Celsius, hot enough to melt iron. The hydrogen around you is now metallic hydrogen, an exotic state of matter where hydrogen acts like a liquid metal. This metallic hydrogen ocean extends for thousands of kilometers into Saturn's interior. It's electrically conductive, generating Saturn's powerful magnetic field through dynamo action. Your spacecraft would never survive the journey. No material we know can withstand these pressures and temperatures simultaneously. You'd be crushed and melted long before reaching this depth. But let's say hypothetically you had an indestructible vessel. You keep descending through the metallic hydrogen ocean. What's at the center? Scientists aren't sure. The leading theory is that Saturn has a rocky core, maybe 10 to 20 times Earth's mass, compressed to incredible density. The pressure at this core exceeds 10 million times Earth's atmospheric pressure. The temperature might be 11,700 degrees Celsius. But here's what's truly disturbing. We can't know for certain what's down there. We've never been able to probe Saturn's interior directly. All we have are models based on the planet's mass, gravitational field, and composition. For all we know, something completely unexpected could exist in Saturn's core. Some exotic form of matter we've never seen. Some process we don't understand. Saturn's interior is as alien and inaccessible as the core of a distant star. And we have a spacecraft, Cassini, that deliberately crashed into Saturn's atmosphere in 2017. It survived for about 45 seconds before being destroyed by heat and pressure. The data it transmitted in those final moments gave us valuable information about Saturn's upper atmosphere. But the depths, they remain a mystery. A crushing, hellish mystery. We haven't even talked about Saturn's radiation yet. This is where things get really scary. Saturn has a powerful magnetic field, about 578 times stronger than Earth's. This magnetic field traps charged particles from the solar wind, creating radiation belts similar to Earth's Van Allen belts. But Saturn's radiation belts are far more intense, and they extend much further from the planet. Any spacecraft or astronaut passing through these belts receives a massive radiation dose. Even with shielding, the exposure would be dangerous. But wait, it gets worse. Saturn's rings and moons interact with the radiation belts in complex ways. Some moons act as radiation sinks, absorbing particles and creating gaps in the belts. Other regions have concentrated radiation. Enceladus, one of Saturn's moons, spews water vapor into space from geysers at its south pole. This water creates a torus of neutral particles around Saturn's orbit. When these particles are ionized by solar radiation, they get trapped in Saturn's magnetic field, creating additional radiation. So you have layers of radiation at different intensities, different energy levels, creating a complex and deadly environment around the planet. Pioneer 11, the first spacecraft to visit Saturn in 1979, passed through unexplored radiation regions. Engineers weren't sure the spacecraft would survive. It did, but received radiation doses near its design limits. Cassini, during its 3-year mission, had to carefully navigate this radiation environment. Its final orbits, diving between Saturn and its rings, exposed it to radiation levels that gradually degraded its electronics. Human exploration of Saturn would require massive radiation shielding, far more than needed for Mars missions or even Jupiter. The longer you spend in Saturn's system, the more radiation you accumulate. And here's a disturbing thought. We don't fully map all of Saturn's radiation environment. There are regions we haven't measured carefully. Any manned mission would be exploring partially unknown hazards. Now let's talk briefly about Saturn's moons, because they add another layer of horror to this planetary system. Saturn has 146 known moons. Some are tiny, just a few kilometers across. Others are planet-sized. Titan, the largest, is bigger than the planet Mercury. Titan has a thick atmosphere of nitrogen and methane. It has lakes and rivers of liquid methane on its surface. It rains methane. The entire hydrological cycle is methane instead of water. Landing on Titan would be like landing on a frozen version of early Earth, but with methane replacing water. The temperature is -179 degrees Celsius. The atmosphere is so thick that walking on Titan's surface would feel like walking underwater on Earth. But Titan isn't the scariest moon. That distinction goes to Enceladus. Enceladus is a small, icy moon, only 500 kilometers in diameter. It looks peaceful, just an ice ball orbiting Saturn. Except it has geysers, massive plumes of water vapor erupting from cracks in its south polar region, shooting hundreds of kilometers into space. These geysers suggest that beneath Enceladus's icy crust is a global ocean of liquid water. Tidal forces from Saturn's gravity heat this ocean, keeping it liquid despite being in the frozen outer solar system. That ocean might harbor life, microbial life, living in darkness, sustained by chemical energy from hydrothermal vents on the ocean floor. But here's what's terrifying. Those geysers are powerful enough to feed Saturn's E-ring. Material from Enceladus gets ejected into space and forms a diffuse ring around Saturn. If you were near those geysers when they erupted, you'd be hit by a blast of water vapor traveling at hundreds of meters per second. It would be like being caught in an explosive decompression event. And this is happening constantly. Enceladus is violently venting its interior into space. It's a tiny world engaged in planetary-scale violence. So let me summarize what we've learned today. Saturn is not peaceful. It's a planet of extremes that would kill you in dozens of different ways. Its winds exceed 1,100 miles per hour and have been blowing for billions of years. Its storms release energy equivalent to billions of nuclear weapons. Its North Pole has a hexagonal jet stream that shouldn't be possible according to fluid dynamics. Descending into Saturn's atmosphere would crush and melt you through pressure and heat that exceed anything on Earth's surface. The radiation belts around the planet would dose you with lethal radiation. Its moons are geologically active worlds engaged in violent processes. Every aspect of Saturn is hostile to human life. There is no safe place in the Saturnian system. Even in orbit, you face radiation. Trying to land on any moon exposes you to extreme cold or tidal forces or geyser eruptions. And here's the final disturbing truth. Saturn might be getting worse. Recent studies suggest Saturn's storms are becoming more frequent and more intense. Climate models of gas giants predict that as a planet's interior cools over billions of years, its atmospheric dynamics might actually increase in violence. Saturn is a 4 and 5 billion year old planet, slowly radiating away its internal heat. As it does, the temperature difference between its hot interior and cold upper atmosphere might be driving more intense convection, more powerful storms, stronger winds. In other words, Saturn isn't settling down with age. It's getting angrier. So the next time you see a beautiful picture of Saturn with its majestic rings, remember what you learned today. Remember that beauty is hiding violence on scales we can barely comprehend. Saturn is the scariest planet in our solar system. not because of any single feature, but because every aspect of it is designed to destroy. And we haven't even mentioned the most disturbing possibility. We might not understand Saturn at all. Despite decades of study, multiple spacecraft missions, and thousands of observations, this planet still surprises us. What other horrors are hiding in Saturn's depths? What processes are we still ignorant of? What violence are we not yet equipped to detect? These are questions that keep planetary scientists up at night, and should probably keep you up too. What do you think? Does this change how you see Saturn? Share your thoughts in the comments. And if you want to learn more terrifying truths about our solar system, subscribe to this channel, because space isn't the peaceful place we like to imagine. It's violent, chaotic, and absolutely fascinating. Thank you for watching. I'll see you in the next video.